All right, welcome everyone to another day about talking about science. And so last time we talked about Kuhn and his belief on how scientific revolutions work. Basically, you have a dominant theory, and over time it'll acquire anomalies, data against it. And if we ever have a model that is better supported by the data than the other one, then pressure could build up, and then at a certain point, the scientific community adopts the other paradigm, which is something called a paradigm shift, a term that has been adopted by people in business. That's a real paradigm shift right there. To mean, I don't know, the way things business are done is different. Something. Okay, so today we're going to be continuing our discussion of science, the state of science. We're going to be talking about the reproducibility crisis, which is actually a pretty big deal right now. How many people here want to work in science? Not talking about writing programs. That's more of an engineering thing. But actually want to work in science of some sort, some sort of science. Anybody? Two people said good morning. Does anybody want to work in science? Kind of. Maybe. No. Physical science? Social science too. Medical research. A bunch of no's and some maybes. All right. So, okay, we got one person who's gonna do it. All right. So, Nathania, this is for you. All right. As a kid, you want to be a scientist. Does that count? So when you were a kid, you were taught the scientific method, right? Like when you're in middle school, they have probably a poster up on the wall and it shows you what the scientific method is, right? And I mean, you guys have all seen something like this, right? Ask a question, state a hypothesis, do an experiment, look at the results, make a conclusion, right? You guys. You wonder who's going to be the next Albert Einstein? Yeah. When you look at this, does this look familiar to you? Yeah. Okay. So that's the scientific method, right? Wrong. This is the scientific method. Start with a problem, then you state the materials you're going to use. Then you state your hypothesis, then your procedures, then your results, then your conclusion. Except that's wrong. There's many other scientific methods as well. So, here's the thing. Yeah, sure, you've learned the scientific method. Here's the thing. There is no such thing as the scientific method, right? There's a lot of things that people call the scientific method that are kind of related. But there's no one universally agreed upon a scientific method per se. And that is the most common one. Well, I mean, look, these are actually different, right? In this one, you start with a problem, you talk about the materials. So what has in common with all these different scientific methods is that you do some sort of experimentation and you check your theories against reality, and you do that in a reproducible way. So that's what all the different scientific methods have in common, but they're all also different, right? Because if you are conducting research on black holes, you don't have access to a black hole in your lab, right? There's no black hole, thing that you can put into a test tube and run an experiment on it, right? So people that are doing astrophysics have to rely upon a different sort of experiment where you have what's called a natural experiment, where you look out there and you're like, oh, look, we found a black hole, maybe, let's see if there's gravitational lensing around it, right? Don't you ask the question based on the problem at hand? Yeah, I don't know if asking a question is even like part of the scientific method, right? Like, I've I don't know, scored papers for, probably hundreds at this point, for scientific, peer review kinds of things. And, sometimes they'll state their question. Like, they'll actually start off with, like, we're investigating if this is, the case. And, sometimes they'll state a hypothesis, sometimes they won't. Sometimes they'll just be like, we want to find out. If you, what is, what psychological traits lead to success in computer science 1? Right? I've read several papers on that subject, right? What psychological traits lead to success in computer science 1, this very class? And so they don't have a hypothesis at all, right? It's all these scientific methods where they're like, state your hypothesis. What are you going to find out? They're like, we don't know. We're going to investigate it, Like, I don't know. Like, and so what they do is they survey a bunch of people, and they do the big 5 ocean traits: openness, conscientiousness, extroversion, A and N, whichever those are, neuroticism, and what is A? Agreeableness, that's right. And so what they do is they survey a bunch of college freshmen. College freshmen are the world's most studied creature, other than probably lab rats. Because, do you guys know why? Do you know why college freshmen are the most studied creature on the planet, especially when it comes to psychology? Like, it's really funny, too, because, like, psychological papers will come out saying, America has a problem with drinking and sleeping around. You read the paper and it's like, for this study, we surveyed 480 college freshmen. Right? It's like, well, okay. Because you're party animals, it's funny. It's because psych classes oftentimes require you to participate in some sort of experiment. And so it's hard to get, people to participate in psych experiments, especially when there's absolutely no trust that the psychologist who is running the experiment is telling you the truth about what they're studying, because oftentimes they will lie through their teeth about what the experiment is actually about. They'll say, we're here to study if happy or sad movies improve your ability to do math, which is actually an experiment I took part in. And but then in actuality, what they're doing is they're testing your agreeableness or something. Like, if 5 people around the table all agree on something, do you agree with them? That kind of stuff. Yeah. So the point is, like, none of these steps are really essential, I guess. With I guess the core of the scientific method, if there is such a thing, is to do an experiment, right? You do an experiment, you observe reality, and you draw a conclusion from it. And it has to be reproducible. And you notice reproducible isn't even on here, right? Reproduce the results isn't even on here, right? And that's one of the core things to science. The Royal Society in England, their motto is nullius in verbo, which means don't take anyone's word for it, right? Run the experiment yourself. And so the whole point of science is that, like, if somebody says, hey, if you add linoleic acid to beans, they'll sprout earlier and grow taller. Like, all right, let's do the experiment ourselves. And like, nope, you lied. That it actually doesn't work. I'm like, what? Yeah. So, I hurt science. Participation is always the most difficult aspect of a psych experiment. Why would they say that? Because they don't want to. They don't like if they tell you, we're going to see if you go along with other people, then you're not going to do it. You know what I mean? Like if they tell you what the purpose of the study is, like, you know, are you just going to go along with the crowd? But then you're going to be like, no, I'm not going to do that. You know, and you put your back up against the wall, and it ruins the experiment. So a lot of psych experiments just completely lie to people about what it's about. You know, like they'll have you solve crossword puzzles for half an hour, and then, you know, you think you're being tested on your ability to solve crossword puzzles, but actually what they're doing is they're testing priming, and they're testing psychological priming by having two different versions of the crossword. One where the words in the crossword puzzle are associated with youth and excitement and energy and moving quickly, and the other set of crossword puzzles are associated with age and decrepitude and arthritis and moving slow and Alzheimer's and words like that. And then the speed at which you solve the crossword puzzle has nothing to do with anything. It's when you turn in your crossword puzzle and they watch you walk down the hallway leaving the experiment. They actually have a timer, and they time to see how quickly you walk down the hallway. And the experiment found that people who walk down the hallway after solving crossword puzzles associated with springtime and youth and cheetahs and stuff like that tend to walk quicker than people who solve crossword puzzles involving canes and arthritis and being old and venerable and things like that. Did DMX die? Sad. That's sad. Yeah. Don't Prince Philip died also. Oh wow. Wow, okay. So they lie to you, right? They lie to you, and then they see, you know, because if they told you we're going to be measuring how quickly you walk down the hallway, it would change how you walk down the hallway. And so it's hard to get people for these things because there's no trust, you know. So college freshmen, because you're mandated. You're mandated by your class to take part in these experiments. So yeah, steps left out: reproducibility, right? Like reproducing. And so, even though the scientific method is treated as this like holy, you know, thing, like a lot of atheists I know, they put their faith in the scientific method rather than, you know, God, because the scientific method produces results, you know. And I think it's like there's no like one thing as the scientific method. In general, you should go about life in sort of a method, in an analytical method, you know, like, you know, don't believe people, test your hypotheses, you know, look at the data, run the stats, you know, always be willing to change your mind. Like there's a collection of kind of related concepts. And so, like I said, you know, an astrophysicist can't test star formation in the lab, so they omit some of the steps, right? And an economist who believes that small penalties can incentivize bad behavior, it's a true story. Like if you provide like a $5 late fee for picking your kid up from daycare, people will very gladly pay the late fee and be late picking up their kid from daycare, right? It's a true experiment. X is going to give it to you, yeah. That's algebra right there. Algebra. So, anyhow, what is the scientific method? Well, as Kuhn puts it, science is what scientists do. So whatever it is that scientists are doing right now, that's the scientific method. Okay, so there is a big crisis in science right now, and some people downplay that it's a crisis, but it's a crisis. You know, you know that when the NSF forms like executive committees on like solving a problem. Like it's a big problem probably. And so 2015, not too long ago, there was a groundbreaking paper in which the authors of the paper didn't try doing new science, they just tried reproducing old science. And this normally doesn't get any attention. And people oftentimes can't even get published if you just reproduce somebody else's experiment. Why? Because you already know about it, right? And so they redid the experiment where they would give people crossword puzzles and they would time them as they walked down the corridor. They tried to reproduce them as closely as possible. They couldn't always, in some circumstances, they're at different universities, and so some different circumstances apply. But what happened was, they measured the people walking on the corridor, and they're like, yeah, we don't see any statistical difference in the two people. And so this landmark paper, which was on psychological priming, right? So it's the phenomena by which one stimulus influences response to a subsequent stimulus without conscious guidance or intention. For example, the word nurse is recognized more quickly following the word doctor than following the word bread. Okay. And so there's many different kinds of priming, and the replicability controversy. And there we go. The interpretation of goal priming is interesting. Recent studies have failed to replicate findings, including the age priming. That was what I was talking about. So, although some kinds of priming are well established, some longer-term priming effects were not replicated in further studies, casting doubt on their effectiveness or even existence. So, the thing is, like, priming was considered a well-established concept in the psychological community, and then people tried reproducing it, and they're like, we couldn't reproduce it, and this was really, really fascinating and really important, because it's not like priming was like some like obscure theory that nobody knew about. It was just taught as fact in psychology classes, right? And this experiment was cited, I don't know how many hundreds or thousands of times in other papers, and nobody bothered to reproduce it. Why? Because you don't get published if you just do some boring like reproducibility study, right? If all I do is just reproduce somebody else's study and I'm like, yeah, found the same thing, that doesn't get me in Nature. You know what I mean? Like, you could probably shop that paper around to a bunch of different journals, and people will be like, yeah, you're not doing anything. You're just reproducing somebody else's work. And so, here's the problem. Have you guys ever heard the phrase publish or perish? Publish or perish. When there was the outliers, yeah. There's a lot of ways to make the data say what you wanted to say, right? And so it casts doubt upon the entire process of science when somebody else can't reproduce it. Of course, the person reproducing it might not be correct either. Never heard of the phrase. Okay. Academia, which is what I'm sort of incidentally part of. I'm tenured, and so I don't have to worry about this. But at a lot of institutions, tenure is hard to get. Do you guys know what tenure is? Tenure. Tenure. So it's related to publish and perish, because if you want to get tenured means you can't be fired. I mean, I guess if you murder somebody, they'll probably fire you or something like that. But as a tenured instructor, like, I can't be fired. The only way I can be fired is if the school goes out of business, more or less. If enrollment drops, then they release tenured professors in the reverse order they were tenured. So the earlier you get tenured, the more job security you have, because they'll fire the most recently tenured people first, right? And they actually have a lottery Like if 5 people get tenure at the same time, they actually have a lottery and they draw which name is the oldest randomly. And so in order to get tenure, you have to publish papers at most 4-year institutions. At a community college, which is where I'm tenured, you just have to be good at teaching, right? And so now that I'm tenured, I don't have to be good at teaching anymore. I can just sit here, drink coffee, and just stare at you guys. But at most 4-year institutions, the way you get tenured is by writing papers. And you need to not only write a paper, you need to get your paper published. And you need to not only get your paper published, you need to get your paper cited, ideally, by other people. And so when you go into your tenure review, you need to be like, look, I've published 20 papers. I have had 2 articles in Nature. I was given the Nobel Prize, and they're like, I don't know if that's good enough. Out you go. Tenure can be amazingly hard to get. Like one of the friends of the family is a full professor at USC, and I believe full professor at USC, and his tenure fight was brutal. Like it was one of the most stressful things he's gone through, and he's a professor, and law, and he passed the JD too just for fun. Passed the bar. So like Cornel West didn't get tenure, right? Like, so do you guys know who Cornel West is? This was recently in the news. Cornel West. So like he came to speak at Fresno City College like 2 years ago. Pretty famous dude, and he didn't get he's been lecturing at Harvard. They didn't give him tenure. Right. So it's kind of like, he's somebody that has a Wikipedia page this big, and Harvard's like, nah, pass. So it's really brutal. That's what I'm trying to say. And so the reason why we have this reproducibility crisis or replicability crisis, there's different names for it, is that there's always this intense pressure to publish new papers and have them be influential and have them be cited by other people. And so, you get the data and you're like, oh, those outliers, we'll throw those away. And you carefully select the data that you want to select. And then you discover, oh, look, it is significant, when it wasn't before. Throw away the bad data you don't like. And of the 100 landmark papers, these are landmark papers. These aren't like random, people writing random things. They took the 100 most important papers in psychology, the 100 most important papers that everybody's citing, that are being taught by everybody, and they found that only 39 of them could be reproduced. And of those 39 that could be reproduced, half of them overstated their effects. So in other words, if they said when people walk down the corridor, they walk 20% slower if they've been primed on old age, and maybe they do reproduce it, but they find they only walk 1% slower or something like that, right? And so this means that if you believed in what everybody in the scientific community believed in, at least in psychology, there was a less than 50% chance that your belief was actually correct. Or it's possible the people reproducing the studies got them all wrong. That's a possibility too. There's no way of knowing, right? Sounds like when social media influencers try to get their photos and word out on the 3 world to get recognition. Yeah. As a it's a really rough situation. It's hard to get a full-time position at a university. Did you guys know this? Like, non-computer science. If you want to be a computer science professor, it's not too hard to get a job. For me, they were like, do you have a graduate degree in computer science? I'm like, yeah. They're like, you're hired. I'm like, cool. That was how I got my first, professoring job in computer science. I had a pulse, But if you are like, let's say, an English major, Usually when there is a new full-time tenure track English spot open, 100 people will apply for it. Like, it is really, really competitive. And then you get your job. You actually are the top one out of those 100. So out of the 100 people with doctorate degrees that have all gone through graduate school and written papers and you know, this brutal, you know, application process where you send out your thing, you apply to every English professorship position in America, of which there might only be like 20 a year. You know, all the graduating PhDs are all sending out the resumes to everybody because all these people want to get a professorship job. Because let's be honest, it's a pretty cool thing. Like, being paid to like just talk to people is like pretty cool. Because most of the time, if I were to talk at them an hour straight, they'd be bored and they would walk away. And maybe some of you guys are bored and walk away. Who knows? I can't see you on Discord, right? But I just get paid to talk to people. It's pretty fun. And so, of those top people graduating from top universities, you got your doctorate in English from Berkeley, and you apply and you get it. You get this tenure track position full time. It is like catching a unicorn. Okay, it is so hard. Most people go their entire lives not able to get a full-time position as a professor. They will take adjunct positions. An adjunct professor is somebody who teaches part-time. They don't get benefits. They don't get tenure. They get fired. Like, if there's just not a class for you, sorry, you're not working this semester. And if you work full-time as an adjunct, you get paid about $24,000 a year, something like that. So you've got a PhD in English, but you really want that professorship position. So you'll adjunct for Duke, or you'll adjunct for Harvard, or you know, community college, or wherever, anywhere they'll hire you. You adjunct, you get paid nothing, and you got these student loans. You're getting paid nothing for it because you're hoping to get the tenure track position. Then the impossible happens. You get it. You're the top one out of the 100 people, and you now have a tenure track psychology spot. Guess what? You're not done yet. You do not need a college degree to work, but you need a degree to get the job. Yeah. In order to get a professorship, you at a 4-year university, you in general have to have a doctorate, right? Like, I don't think I could work at Fresno State full time because I don't have a doctorate. I could be wrong about that, but I can only teach freshman and sophomore because I have a master's degree. Okay. So I would not be eligible for tenure at Fresno State. At a community college where all we do is teach freshman and sophomore, yeah, sure, I'm tenured. But let's say you're a brand new psych professor. You've now got 4 years, 6 years, 8 years to prove yourself to the college. And so you've got to work your butt off doing groundbreaking research. Ideally, you're not going to be reproducing old studies because, you know, at the end of the 6 years, it's like, what did you do to make our college look good? And you're like, I took a bunch of old studies and I just was like, yeah, they work. You don't get tenure. Tenure can be very hard to get. And so you grab that unicorn, you have the job, and then they don't give you tenure, and you're fired. Can you imagine how heartbreaking that is? Right? You've been at Duke University for 6 years. You've published 20 papers, and they looked at them and they're like, nah, they're not really good enough. You didn't do any groundbreaking research. Get out of here. And they'll fire you. They'll fire you. You have to make tenure and be permanently employed, or they fire you. And there's a lot of politics involved in that. Or it can be. At my institution, they're like, yeah, you seem fine, tenured. Right? I really like working at a community college. I really do. You know, it's a different environment. It's a lot less stressful. Yeah, so you're the one English person out of the 100 to get the job, and they're like, no, you didn't really contribute enough to the literature, and you're back on the streets. You know, yeah, it's really sad, and it you know, at some institutions, they don't give tenure to most people, right? So, yeah, you got to be political. You gotta kiss up to people. You got to make sure that, you know, and the friend of the family at USC didn't, like, he was in a tenure fight. You know what I mean? He was in a tenure fight and published books. He was friends with Oliver Stone, the filmmaker. Like he was doing a lot of stuff and barely got tenure. And so that's what drives this, right? Publish or perish. Like one of my favorite professors at UC San Diego, the other professor quipped he chose to perish. He didn't publish enough papers. He only published a couple papers a year. Not good enough. Not good enough. And then he went to work for Google and made Chrome OS. So, worked okay. So, it's brutal. And so the American Psychological Association defended their field, despite only 20 out of 100 papers really being reproducible, saying, well, it's a problem in other fields too. Do you guys know what fallacy this is? What fallacy is it? Other fields have similar problems. They just picked on us because we're psychology. You guys remember the fallacy? I said, all the topics we talk about are going to keep coming up over and over again. Put all the tenure nominees in a coliseum. Yeah, I'd be fine with that. Do you guys remember? Well, you do it too. China recently has been responding to America's criticisms of their treatment of the Uyghurs in Xinjiang province by saying, well, America has civil rights problems too. In other words, not defending themselves so much as saying, well, look at Derek Chauvin and George Floyd and things like that. Yeah, it's too cool. So classic response right there, classic fallacy. The APA, which really should know better, you can read the link there. They said, well, it's a problem that other people do. Don't pick on us. and the answer is, well, and my response to that is, yeah, it is a problem in other fields too. It's a problem throughout science. But it's particularly bad in psychology, right? So yeah, publish or perish is brutal, and it pushes academics to find new things in psychology that nobody's ever discovered before. You can't fire me. I discovered age priming, You can't fire me. I discovered implicit bias, And so if your name is on that landmark paper, they're not going to want to get rid of you. You have brought honor to the family, right? When my daughter finally learned to use chopsticks when she was about 5 years old, she's like, Daddy, I'm so happy now. I'm like, why? She's like, I won't bring shame to the family anymore. That's my wife would always tell her. You can't use chopsticks. You're 5 years old. Bringing shame to the family. And so if you can't come up with a good landmark idea, then you just shovel out papers. Shovel them out. And man, I have read so many CVs where it's like they publish the same paper over and over again. It's like every quarter, update on this, update. And every quarter they publish an update paper. And when I referee papers, when I do peer review, I'm just like, no. Like, what's happened since, like, it's a cool idea and I see why it got published before, but you've done nothing in the last 3 months to warrant a paper being published. So I tend to reject them. Very common though. Like I said, a lot of CVs, and these are published papers, and they'll have 100 citations to their name in, like, I don't know, 5-6 years, And when you're going for tenure, you want to have a long CV, curriculum vitae. So your resume, if you're an academic, it's called a CV, curriculum vitae. And so they will just pump out these papers, right? And so here's the thing. If all you do is just reproduce somebody else's thing, you're like, yeah, we didn't find anything cool, they were correct, it doesn't get published. And so people don't do it. And so this has created this giant bias in science, where the scientific community, the incentives in the scientific community are set up such that people want to produce new papers and not check old papers. And therefore the scientific method failed, because a big part of the scientific method is reproducing results and actually checking to see if the people were telling the truth or not, right? And it turns out in the majority of cases, for the most important papers in psychology, we're not even looking at low quality papers. These are the highest quality papers in psychology. Only 80% of them, well, 80% of them were either lying, maybe, about the effect happening at all, or they overstated the effect. And so you can shop your papers around. You don't get in at Nature, then you try a lower tier journal. If that doesn't get in, you try a lower tier journal. So you shop it around until you find a place that will publish you. Some journals are notorious for just publishing everything. You pay them money and they will publish you. And so if you do that a little too often, then it'll be like, okay, you've got nothing. And some of these journals are well known, but shopping a paper to lower and lower tier places is a great way of building up your curriculum vitae. Okay. Oftentimes, in order to get publicity for your work, because if you have publicity, you're more likely to get tenure also. They will send it to like a news, like a science news reporter, right? And you can't fire me. I discovered the 4/5 of your studies wrong. Oh, that's why you're firing me. Yeah. Don't try to reproduce the papers of the people whose institution you're at, because both outcomes are bad. Either you're like, yep, they were right, and I have nothing interesting to say, or you were wrong, and then they fire you anyway. So, it's really rough, and it's honestly, the state of academia in America is really sad. Not because it doesn't work, right? Like it, for all its faults, America's research industry is really good. We're number one in innovation in the world for a reason. But it is, man, human factors of that. Brutal. So, then you have outright fraud. So if you, somebody's calling me. Then you have just outright fraud. And so, a lot of these factors, these are like systemic factors, right? Like, shovel out the papers, that's due to pressure. And just a lack of interest in reproducing things. Those are just big systemic factors that lead to these problems. But then there's just outright fraud, or maybe some weaker term I could use. Sometimes it's deliberate, sometimes it's not. Let's put it that way. And so the way that science works, if you really want to know, I've talked about this before. I've talked about cherry picking a couple times in this class already. Is that if you want to know something, if you want to know if something's real, you have to do the stats. Statistics are the backbone of science. Okay. Statistics are the backbone of science. If you're going to become a psychologist and you don't know stats, you're not going to get anywhere, right? In academia, right? If you want to become a therapist or something, more power to you. But the way that science works is you have a hypothesis, right? And you're like, okay, we want to see, is it true that if I apply linoleic acid to beans, they will sprout earlier? And so you take a bunch of beans, you coat them in with linoleic acid, and then you take a bunch of normal beans and you plant them. Classic science fair experiment, right? And then you measure the time it took to sprout on each of these things, measure maybe the height of them over time, et cetera, et cetera. And then you ask the question, did it make a difference? Did it make a difference? And you've got numbers, like you got all these numbers. Are they significantly different? And that's where there's a lot of different statistical tests. There's the student's t-test and ANOVA, and it doesn't really matter how you get it. But at the end of the day, after you run the stats, you're going to get a number, and that number is can be interpreted different ways. But in general, you'll see on a scientific paper something like this: P is less than 0.05, and that means there is a 5% chance. To really oversimplify this, there's a 5% chance we're wrong. Right? There's a 95% chance we're correct. And sometimes, if your data is good, it'll be P is less than 0.01. So we are 99% confident it's correct. And again, I'm having a small stroke over here because that's not actually what it means, but it's kind of how people interpret it. So, and if you have a really good paper, it could be p is less than 0.000001. You know, if you're damn certain, if the data is overwhelming, you can be 99.99999% certain that something is true. Okay? But in general, if you want to get published, you have to hit this number. That's kind of, you know, in hard sciences, it's more this, and soft sciences, it's more this. Soft sciences being things like psychology, sociology, things like that. They tend to have weaker, less rigorous standards. And what's hard science? The classic hard science is physics, right? CERN over at the border of France and Switzerland have what's called the Large Hadron Collider. Don't say that word wrong, by the way. It's a Large Hadron Collider. And they smash particles and they gather data. And what's really nice about particles is that there's always more particles to smash. And so they can just keep running the experiments over and over and over again, gathering as much data as they need in order to become 99.999% certain that something is true. In psychology, you've got a class of freshmen. The numbers are what the numbers are. You know what I mean? It's hard. You know, it's very expensive to do bigger trials on drugs and things like that, especially. So, other hard sciences are chemistry, biology. Medicine, though, has a big problem with this as well. Drug trials, especially. And so here's the thing. So let's say that you have your data. You have your, like, let's say you gave a drug to somebody and you wanted to see if, I don't know, it stops coronavirus, right? And like the vaccine, like when they did the vaccine testing, they had big trials. It's because everybody wanted to get vaccinated against COVID, which is unusual. And so they had 40,000 people in their phase 1 and phase 2 trials, I believe. Some giant number like that, which is way bigger than you normally get. But that was nice because it allowed us to get good data. Right? And so they would give some people the vaccine, some people would get a placebo, and then you check to see what percentage of people in each group came down with COVID after 3 months of just being out in the wild. And then you get a p-value. You do the stats, you get a p-value, and you're like, p less than 0.01, the vaccine is effective. But here's the thing. Let's say that your numbers are like 0.06, not quite enough to get published. You know, and so what p-fishing is you're like, all right, let's rerun the experiment. P is not worse. Rerun the experiment. Oh, better. We dipped right below that threshold. All right, that's the one we'll publish. Right? You just kind of sweep under the rug the other results. So you sweep under the rug all the negative results. You only publish the positive one. And you can keep, like if it's marginal, you just keep rerunning experiments over and over again until random noise causes it to dip below that threshold. And that's one of the reasons why studies don't reproduce. It's because it actually was due to random chance, but they just keep trying until they roll the dice and get boxcars, you know? Or like what somebody said earlier, you throw out your outliers, right? It's like, oh, well, clearly this data is anomalous. You just throw it away. Oh, look, we went below the 0.05% threshold, because if you want to get published, that's usually the threshold, right? And so if you're at 0.06, you just throw out data until you dip below 0.05. That's outright fraud, right? If you do it intentionally. But, you know, sometimes you have outliers. You know, you measure somebody's height and you get a negative number. That's impossible. Throw it out, right? That's what you do in the lab to get the results you want. Yeah, it's unfortunately common. And you have to get rid of outliers, right? Like, and so, you know, if there's discussion over which data we should get rid of, a lot of times they'll look at what the effect will be on the p-value. You're like, all right, let's get rid of that one, you know, and then published, right? And so all the pressure, all the influence, all the incentives on science is to have landmark papers that show a real effect. And so you would think that if we use a 95% confidence threshold, which again, it's not actually what it means. You would think that 95% of papers would reproduce, but in reality, it's like half, right? And of those half that reproduce, half of them overstate the effects, right? And so that it's a real serious problem. It's a really serious problem. The hard science research are more scientifically more reliable. Yeah, just because, like, if you're studying to see if one chemical mixed with another chemical forms another chemical, you just do that over and over again. You know, you just buy more chemicals. You know, and whereas in psychology, like, people don't like doing psych experiments because they don't trust that they're being lied to. You know, and so you just have a limited pool of freshmen, you know, that are in Psych 1 or whatever that you can experiment upon. And you've got to, you know, and so it's just the nature of, you know, like I said, every scientific discipline is different, you know, and how they go about the testing is different. It's not saying that psychology is bad. In fact, I want to emphasize, I'm not picking on psychology here. It's just, you know, humans are big, messy creatures, right? You know, particles behave the same way every time. Chemicals behave the same way every time. Whereas if you're studying something like, does teaching over Zoom work better than Discord? Do you have the same professor? Because how the professor teaches makes a huge difference. You know, the students are different in each class. You know, we're big, complicated things, and it's hard to, you know, we don't fit into a test tube. I'm in Psych 10. I'm required to participate in at least 9 studies. Holy smokes, dude! 9 studies. Man, when I was a freshman, it was 3. My goodness, right? So, if you want a good book to read on the subject, it's this book right here, How to Lie with Statistics, and this will guide you to success and tenure in the sciences. So this was actually a required reading when I was in my stats class, and so. It talks about all the different tricks that scientists will play with statistics. And use your powers for good, not for evil. That's my advice to you. Remember your morality training. But if you read that book, it's a really short book, and it's free, too. How to Lie with Statistics. It's old enough that you can actually find copies that are out of copyright. It will help you understand how bad science is a lot of times and how bad science reporting is. Science journalism is really, really bad. Okay, and so you know, don't let this dissuade you from believing in science. But one thing you should be aware of is if there is just a preliminary result, like if somebody publishes a preliminary result saying that eating pretzels makes people more aggressive, until it's been reproduced, I'm just kind of like, oh, okay, that's interesting. You know, it's so easy to find some sort of clickbait title, you know, road rage explained by pretzels, you know, and I could probably design an experiment that would prove that pretzels cause road rage. You know, I'd give them pretzels and no water, and then say, "Do you feel irritated?" You know, yes, I do. Cool, neat. So now you know, and so the science journalist will say, road rage cause has been found. It's due to pretzels, and the actual experiment didn't say that. Maybe the experiment was just like, do people get annoyed if they eat pretzels and no water? Yes, and then that mutates in the science reporting world to, you know, the cause of road rage has been discovered, you know, or something like that. I talked earlier about how I went down the rabbit hole chasing down if rich people were cutting the line on vaccines, and every time a reporter covered another reporter, the headline got progressively more dramatic and detached from what was actually happening. And so you have to be really careful when you read a story online. Like, a lot of people just read the headline, right? Elon Musk benefiting from the pandemic. Okay, how is he he's exploiting people. And I read the story, and it's like, his wealth has gone up $15 billion since the pandemic began. And everyone's like, oh my gosh, look at this. He's profiting from the pandemic. He's sucking $15 billion out of hardworking Americans during this time of crisis. I click on the link, and it's like, Elon Musk's stock has gone up. Well, okay. He doesn't actually have $15 billion. All that happened was the value of Tesla went up. He didn't, like, stock prices go up and down. You know, sure, his wealth went up, but, like, none of this was like $15 billion sucked out of hardworking Americans. And, you know, maybe more people are buying Teslas now, but people are buying Teslas because they want to buy a Tesla, you know. If Teslas were cheaper, I would probably buy one, you know. Doesn't mean that he's profiting off the pandemic and you know, like, people, but people, like, I was on it, and I was on Reddit probably, and all these people were talking about, see, everybody says Elon's a good guy. You can see from this story headline, because I didn't read the whole article, they don't say that part, that he's exploiting the American people. And it's like, no, the stock prices went up. It has no connection to reality of sucking any money out of anybody. Stock prices go up and down. And so in general, most people I find on the internet read the headline. Elon is profiting off the pandemic. And then they're like, see, that confirms my belief that Elon is a bad person. Because remember, we talked about confirmation bias. Anytime you see something that agrees with you, our threshold for accepting it is very low. Anytime we see things that disagree with us, like if you love guns and you see an article saying gun ownership is associated with more shootings, your threshold, I'm going to stare at that article and see if I can find any mistakes in it. And so our threshold for accepting things depends upon if we're already predisposed to accept it or not, right? And so my advice to you, and contra-wise, like if you think that guns are evil, and a study comes out showing that, you know, gun ownership, the same study maybe, they're inclined to believe it. Like, oh, well, I don't even need to read it. I already know that's true. And so my advice to you guys moving forwards is don't just read headlines. You know, when somebody says, here's this thing that will change how you have to behave, you know, because pretzels are the cause of road rage, click on the link. Don't just read the headline. Click on the link. Read the story. Try to figure out what data they were actually looking at. Look at the p-value. If they don't have the p-value, I go, right? I have absolutely no reason to believe you. You know, if I can't find the actual citation, if it's not in a peer-reviewed journal, I'm just like, it's just a guy publishing some things, you know, whatever. You know, just some dude, you know, spitting ideas and opinions out. Who cares? And so if it's in a peer-reviewed journal, and a good peer-reviewed journal, and it's got a p-value, and it's got an effect size, then I'm more inclined to believe it. But until it's been reproduced, again, you know, it could be, you know, even if it's a landmark paper, it's like flipping a coin. So, you know, it's not like you shouldn't believe anything, but you should sort of apportion your belief to how much evidence there is for it. That's what it means to be a critical thinker. A critical thinker apportions belief according to the evidence, right? And science journalism, unfortunately, I wish it was different, you know, but, you know, they're all fighting over clickbait titles, you know, BuzzFeed. Right? Teslas are awesome, yeah, but they're pretty expensive, so I don't drive one. I used to drive a hybrid, actually. That was fun. It was neat driving a hybrid. Yeah, and so basically just look at the evidence, see what kind of data there is, see if they have a p-value, see if it's been reproduced, and if it's a really strong result, you should believe it, even if it disagrees with you. Even if it disagrees with your biases. If there's strong, reproduced statistical evidence, it's got a good p-value on it, yeah, it's like, that's the evidence, you gotta believe it, you know. Or even go beyond that, look at the meta-study. If there's been 15 studies published on the subject, what is the meta-study looking at the studies? What does that say? You know, but there's no substitute. There's no substitute for actually doing the hard work yourself. And unfortunately, I wish I could say otherwise. I wish I could say, yeah, when CNN says the results are clear, you could believe CNN, but you can't. You can't. you have to actually go to the source and look at the numbers and look at a meta review, like the meta analysis and all this stuff. And yeah, and it's really kind of sad because I would like to be able to just read a headline too and then go on to play, video games. But can't. So you can sign up for the California grant. Takes money off for being electric. Yeah. Everyone's got an agenda. Yeah. I mean, and the agenda for science reporters is just, I want to make money. I want clicks. And so they come up with the most clickbaity title ever. Among Us causes suspicion among friends. Yeah. Okay. Cool. Yeah. And so, yeah. I wish I could end this on a more positive note, but the sad reality is you got to just put in the time and effort to check your sources, check the primary sources. That's why I'm having you guys do this on the peer review. So Monday, do the scavenger hunt. Find 5 URLs out there, and then the peer review is you checking those URLs. Okay, that's why I'm having you guys do that. I want you guys to get into the habit. Somebody claims something, click on the URL and see for yourself if it is what they claim. Okay, so peer reviews due on Monday, and I'll probably put up a reading as well. Okay, that's it for today, guys. Thanks a lot. $1 bills, y'all.